All right, we are going over the Unit 4.1 quiz review. So let's start with number 1. It says, translate the following chemical equations into words. Okay, so for this first one, I would say hydrogen gas and oxygen gas produces water. You don't need to say liquid water. That is just redundant. All right? And for the second one here, we're going to say aqueous magnesium chloride and silver 1 nitrate. The Roman numeral 1 is because silver is a transition metal. Nitrate is always a -1 charge. Since 1 silver is canceling it out, silver must have a +1 charge. Aqueous magnesium chloride and aqueous silver 1 nitrate yields solid silver 1 chloride and aqueous magnesium nitrate. Number 2, what might you see, like colors, if you observe the following reaction? So aluminum, I know about aluminum. Aluminum is a silver metal added to a solution, and reddish brown solid forms. I say reddish brown because you guys know this. Copper is a reddish brown color. And there could be other things that happen here too, like a color change of the rest of the solution, but I would not expect you to know that. And the whole point here is that you're understanding that you can add a solid to something and see a new solid precipitate out. Number 3, I think, is the hardest on this whole review sheet because you have to translate the sentence into a balanced equation. So there's a lot of work to do here. So aqueous sodium phosphate, sodium's a +1 charge, phosphate is a -3 charge, so that's going to be Na3PO4 aqueous, and aqueous nickel 2 chloride. Nickel's got a +2 is what that Roman numeral is telling us. Chlorine is a -1, so this will be NiCl2 aqueous. Form sodium chloride solution. Sodium +1, chloride is a -1, and solution means aqueous. And nickel 2 phosphate. Nickel's a +2, oh, it says solid, sorry. PO4 is a -3, so this will be Ni3PO42 with a little S, sorry, I'm running out of space, for solid after it. Now, this is not balanced. A good strategy would be to start with something other than the oxygens. So I'm going to start with nickels and see where that's where that gets me. Ni3, 3 Ni. PO4, there's just one of them, and on this side there's 2. So I'm going to do 2 out front. Now I've got 2 times 3, 6 sodiums, so I'm going to need a 6 here. And then double check my chlorines. 6 chlorines, 3 times 2, 6 chlorines. So the coefficients are 2, 3, 6, 1 in front of that Ni3PO42. So there's a lot of work to do in that little question. All right, number 4, we're going to get some more practice with balancing. So let's see. 2 fluorines here. I only see 1 on the right side, so I'm going to add a 2 there. Now I've got 2 NAs, so I'm going to need a 2 here. 2 chlorines, 2 chlorines. That looks good. Next one down here, I do not want to start with the oxygens. Be3, so 3Be. PO4 2, this whole thing stays together, so I can put a 2 here. 2Fe, 2Fe on this side. That makes 6 chlorine and 6 chlorine on this side. So now we're balanced. Law of conservation of mass. Mrs. Baker bought 1 pound of dry ice. This is so far-fetched. I would never buy that little. Just kidding. She accidentally left it out on the counter for an hour. When she weighed it again, there was only a half a pound left. How is the law of conservation of matter followed in this example? Where did the mass go? The carbon dioxide molecules went into the air. They turned into a gas. And gas has mass. So just because now they're not on the scale doesn't mean that they disappeared. Number 6, identify the type of reaction. If you've got a single element added to a compound and you're getting a single thing kicked out, that is single replacement. If you've got 2 compounds adding together, the first 2 things are switching places, that is a double replacement reaction. 2 single things becoming a compound, that sounds like combination. And 1 compound breaking down, that is decomposition. Okay? Number 7 is just like the hardest part of the quiz that you're going to be taking at the end of this. And that's because it's all the different types of reactions and you have to complete them and balance them. And it says include state of matter. Okay? Although I'm not really going to have you do that on the quiz. So let's check this out. Al plus F2, that looks like a combination reaction. 2 things adding together. Al is a plus 3, fluorine's a minus 1, so that will be AlF3. That is an ionic compound, so that will be a solid. This is not balanced. I'm going to make odd numbers even. So I want to make that be 6 fluorines instead of 3, which means I need a 3 out front to make that 6. And a 2 out front in the Al to balance that. Next one, I've got to check my activity series because this is a single replacement reaction. I need to check to see if magnesium is more powerful than copper. Turns out it is. So now copper got kicked to the curb and magnesium is now with nitrate. Magnesium's a plus 2, nitrate's a minus 1, so that becomes MgNO3 in parentheses 2. And that's balanced. That's the good news. Copper would be a solid. I see this is aqueous here. I'm going to check my double displacement sheet, my solubility table I mean, and anything with nitrate is soluble. So that would be aqueous. Is silver powerful enough to kick out copper? Turns out it's not, so I just write no reaction. Next one down looks like a decomposition reaction, a divorce. So Ni is splitting up from Br, so I write that, and then I check Hofbrinkel. Is one of those elements part of this mnemonic to remember the 7 diatomic elements? Yep, bromine is. Now this is not balanced. By the way, nickel is a solid, bromine is a liquid. So I'm going to make odd numbers even. 2 times 3. So I'm going to need a 3 there, and I'm going to need a 2 in front of my nickel. Next one, another single replacement. This is a single thing. It's a nonmetal trying to kick out the Br. So can it kick it out? Yep. Bromine is not as powerful as chlorine, and now Na is going to be with Cl. It's a new relationship, so I need to check charges here. I do not need the 2. But Br is alone, and it's in Hofbrinkel, so that does need a 2. Bromine, again, is a liquid. Sodium chloride is a solid, because that is ionic. And we're going to need some 2's to balance this out. 2Na, 2Na. Now my chlorines are good. Last one. This is a double displacement reaction. Calcium is now going to be with phosphate. So I'm going to crisscross my charges here because calcium was a plus 2, phosphate's a minus 3. Okay, and then sodium is now going to be with nitrate. Sodium's a plus 1, nitrate's a minus 1. So we're good there. Now let's balance. Ca3, 3Ca. PO4, 2, 2PO4. 2 times 3, that's 6Na. And let's double check. Yep, 3 times 2 on this side, that's 6 nitrate. So we're good. Last thing, we need to check our solubility table. Calcium phosphate, it says when you match those two up, not soluble. So that's going to get a little S. And sodium nitrate, it says it is soluble. So that gets an AQ. All right, hopefully that helps.